So here we're going to give a demo of how our chord implementation works. So to start, I've got a simple topology with just two hosts set up, and I've SSH'd into them on the right here. The top is the host 1 at 10.0.0.1, and the bottom is going to be host 2 at 10.0.0.2. So what we're going to do to start is I'm going to start a simple little script. This just creates a new node. It doesn't start a new ring or anything. It just bootstraps it for us so we can play around with it. And so what it does is it creates a new node at the IP address on the particular port. Now this hasn't actually started or anything, but what we can see from the get-go is we've got an address. Now there's always an address. And the address is just the SHA-1 hash of the IP and port concatenated. So it's basically the string starting here and ending here. And in this case, that hash is to 48299. We mod it based on the key space, and the key space is the factor of the number of bits that we want to use. So if we go down here and we do the same thing, the only thing we need to update is to make sure that we're always using the IP address of the host that we're running the script on. We can now see in this case, the hash is actually relatively close at 50866. So let's start a new ring. At the moment, actually, first we can see that there is no successor on the node, and there is no predecessor on the node either. And if we look at the finger table, currently there's absolutely nothing in it, which makes sense because node successor is actually just pulling the first entry in the finger table. The first entry is always the immediate successor of the current node. Okay, so let's start our ring up. Okay, so when we create our ring, the first thing that we can notice is we actually have a successor now, and it's ourself. Now this makes sense because when there's only one node in the ring, that node is responsible for every possible key in the key space, which means that it has to be its own successor. However, critically, there is no predecessor. We're only ever going to be walking forward. We never really walk backwards. So the predecessor is really just used for maintenance and stabilization. So the next step is to make sure that we can actually join. So if we want to join an existing ring, we need to make sure that we have an IP address for it. And we want to make sure we have the right port. Okay. So the node has joined the ring, and its successor is 48299. So this says, okay, we're going to reach out to the existing node and ask what our successor ought to be. Now, in this case, it's relatively trivial. There's only one node in the ring, which means that obviously that node has to be the successor. But critically here, this doesn't actually tell the node that we reach out to anything about how it should update or whether it should update. And this is important because we don't know whether or not the node that we're contacting is going to be a predecessor or even in our finger table when we join. So if we look at the finger table here, we can see that there's exactly one entry in it. That is our successor. So everything worked exactly as expected. But if we look at our finger table here, it's still the same. We haven't made any updates there. But our successor is still unchanged, and we still don't have a predecessor. And we don't have one over here either. So the way that that gets fixed, there's two maintenance functions that get called periodically. And that's stabilize and fix fingers. So let's look at stabilize first. So what stabilize does is it reaches out to our current successor and asks for its predecessor. Now the reason for that, if we think intuitively, what we're saying is, hey, whoever I think is next on the ring, tell me if there's anybody in between us that I don't know about. So in this case, there won't be. But if there is, the other thing that it does is it reaches out and says, okay, so whoever is actually supposed to be between, even if my successor is correct, I want you to know that I exist. because I want to give you the opportunity to update your predecessor to me if that's appropriate. So when we call stabilize, this is going to first reach out and say, hey, who's your predecessor, so that I can update my successor pointer if I need to. And also, whoever that is, whoever your predecessor is, if it's nobody, I know it's you. I exist, and maybe you want to update your predecessor pointer to me. So if we look at our predecessor now, we can see that it actually points back. So now we've got a partially complete link. But this node still doesn't have a predecessor. And that's because our original node has not called stabilize yet. So stabilize needs to run on every single node periodically. So if we call stabilize here, if we check the predecessor, we can see now again we have a full link. So now the other function to look at for maintenance is fix fingers. So now what fix fingers does is it walks the table. Each time it's called, it fixes exactly one entry in the finger table. So the first time it's called, it fixes this one. The next time it calls, it fixes the next one, and so on and so forth. Remember, each finger in the table is responsible for keeping track of the successor of the node that is 2 to the index away from the start. So this is going to be 2 to the second away from 4, 8, 2, 9, 9, to the third, to the fourth, so on and so forth. So if I call fix fingers here, and I check our finger table, we can see there's an entry here. Now it's the same because we're still in the space that's between the actual successor and this guy. But if we call this enough, we're eventually going to see that we're actually pointing back to ourselves. Now, if we think about this on a ring, we've got 4, 8, 2, 9, 9 at the top, and we've got 5, 0, 8, 6, 6 over here. Every node that falls in between these two, obviously the successor is going to be that actual successor node, but everything after that, the successor of every node on the rest of that ring is actually going to be ourself. So as we can see, the finger table is always going to be updated to point to the correct place, even as we get further and further and further away.